Good morning, everyone. Today we are starting our next chapter, Chapter 1. We're going to skip section 1.1 and head right into 1.2, which are notes on functions and domain and range. So our objectives today are to be able to determine if a relation is a function, given a table, given a set of points, an equation, or a graph. So that's some review from Algebra 1 and Algebra 2. We're going to find the domain and range of an equation or a graph, and today we're going to focus on the graph part of that objective. We'll get to the equation part of it later in the chapter, and then we're going to evaluate a function. So for today's notes and some of the notes in this section here early on, I have provided a PDF copy of the notes. Those are in Schoology with this video. So if you would like to either print off that PDF or annotate that PDF, you're welcome to do that. There's just some diagrams here that would make it go a little faster for you if you did that. If you're in person, then I'll definitely provide copies for you if you would like to utilize those. You can always still just pause it and write those in your notebook as well. So here we go, some definitions that are going to be important for today and moving forward. The first one is a relation. So a relation is any set of ordered pairs. So if I give you a coordinate point x, y, every set of those, so set just means multiple ones, would be a relation. The question becomes whether or not a relation is a function. Okay, and to be a function, you guys first learned about this back in Algebra 1 at least. So for every input, there's exactly one output. So we're going to have to be able to determine that from the variety of methods, a table, set of points, an equation, or a graph. So we'll look at various aspects of that. Hopefully that will come back to you. Then we're going to be talking about domain and range. So domain would be our inputs, okay, the things that we would put into the function. They're also called the independent variable. Okay, they are the x coordinate. So domain goes with x. Okay, that's the independent variable on a coordinate plane. The range would be our outputs or our dependent variable. Those are our y values. So I always think alphabetical order. Domain comes before range, just like x comes before y. So if you struggle with remembering which one is which, that's a way that you can think about it. We typically also say domain and range, not range and domain. So domain and range would go with x and y. So again, we're going to be looking at how to find the domain and range, and today we're going to focus on a graph, but we're going to eventually get to how to do that with an equation. So we're going to start off with just determining a function. So this was our first objective. So we need to be able to determine if a relation, so here I have for part A a set of points, okay, is a function. And so I didn't even give you a table here. We could take this and we could put it into a table. So if you prefer to do this from a table, you could definitely do that. So if I took these points, I'll do it on the first one. My input is 1, my output is 6. My next input is 2, my output is 6. We have 3 and 8, and we have 4 and 9. So if you prefer a table, you can definitely look at that. But what you're looking at are your x values. For every input x value, do you have exactly one output? So for every number 1 here, this first one, do you only have one output? And that output for the first one is 6. So if you have another 1 in the x column, it must give you a 6 out. Okay, well, I don't see any other ones, so I'm good there. So I go to 2. For every 2, is my output the same? Is my output going to be a 6? And again, I only have 1, 2. So what I notice is in this x column, everything is different. So if all the x values are different, it's automatically a function. So I would say yes. And again, the reason is, and you want to get this in your head, you need to commit this to memory if you haven't already. For every input, there is exactly one output. It doesn't matter that the outputs are the same. Okay, but for every input, there's exactly one output. We're going to come back to this one in a second to show you another way that you could look at that. So then the second one that you see there in your notes, again, if you're not using the notes, then you're going to have to pause this to take some time to write these down. But you'll see for part B, we have the set. And again, you'll see the little braces here, okay? Those little funky brackets, those little braces, that just says it's a set. So these are just representing multiple ordered pairs here. So we have 6, 1, 6, 2, 8, 3, and 9, 4. So I'm going to go ahead and put those in a table so we can kind of visually see it the same way we saw the last one. So again, the definition of a function, for every input, there can be exactly one output. Well, I hope you're seeing here that you have a 6 that gives me a 1 and another 6 that gives me a 2. So here's my issue. The number 6 gives me 2 different outputs. So that's automatically a no. Now, if I go back over here to this part A, if I would have had a 1 later and then had a 6, that would have been okay. As long as the output is the same for each input, all is good. And again, I'm going to come back and show you another way here in just a brief moment on how you could look at this. But that's how you would tell from a set of points or from a table. You'll notice I just put them in a table. So there's kind of 2 of the 4 that we were looking at. The next one is the vertical line test. And this should be familiar to you, but this is where you're going to use a vertical line to identify graphs in which y is a function of x. So what that is saying really is a fancy way of saying, again, the word function. For every input, for every x value, there's exactly one output or one y value. So every time you put in an x number, 1, you always get the same thing out. Every time you put in a 2, you always get the same thing out for that particular function. So the vertical line test is simply take a vertical line, pass it through the graph. Okay, as you pass it through the graph, if it touches in more than one point at the same time, it is not a function. So this would automatically fail very quickly the vertical line test. It would be fine to start with. Sorry about that. See if I can grab it. It would be fine here. It's fine here. But the moment I come into this function, it's not, or this relation, excuse me, it's not a function. Okay, so again, it touches, I'll just throw a vertical line through there. It's going to touch it in more than one point. So if we look at the next one, if we pass this vertical line through it, I can grab a hold of it, maybe. Okay, pass the vertical line through. Does it pass the vertical line test? Does it only touch this vertical line one time in each location? And I think you would say yes. So this is a function. Now there's something special about this function. Hopefully you would know this is a line. This is called a linear function. So back in Algebra 1 and Algebra 2, you would have even used the word function to describe a line. There's only one line that is not a function. Hopefully you could recognize it being this vertical line. If I graphed a vertical line, it would not be a function because once it touches, like let's say the y-axis, that's x equals 0, it would fail the vertical line test. But every other line is a function. And if you start thinking about what the equations look like, okay, we'll talk about those eventually. Okay, the next one, if I try to pass this line through this next parabola shape, it does seem to pass the vertical line test, so that would be a yes. Again, back in Algebra 1 and Algebra 2, you had a name for this. Okay, this was called a quadratic function. So again, notice that word function is automatically telling you something about the graph. It means that it will pass the vertical line test because every input has exactly one output. And then this last one, as we look at it, okay, and we take that vertical line through it, hopefully you're going to recognize pretty quickly that it does not pass the vertical line test. Okay, because again, if I were to come over here, let's say this value is 2, you would go up to a number and you would go down to a number. So in my table, we thought about a table, you'd have 2 and then let's say positive 1, and then you'd have 2 and then negative 1. Okay, if I'm just making up those values, but that would be a no. So if you go back to part A, you know, that looks kind of like a football or an eyeball. Okay, we don't have any football function or eyeball function. That doesn't have a special name. It's made up of 2 functions, this top function here and a bottom function that you have to put together to create that graph. The same for D. You would have to have this is a square root function positive, this is a square root function negative, and that's what would create that relation, that graph. So back here to this, these ordered pairs, I said I'd come back to this. What you could do, and I'm going to do it on part B, is you could sketch a graph of these. So let's say we went out here to 6. So 6, 1, 6, 2, 8 would be 3, and 9 would be 4. You'll notice that it does not pass the vertical line test. Okay, if I could actually draw a vertical line, but it would not pass the vertical line test. So that's another way, if you're not certain about ordered pairs, put them in a table. But if you're still not certain, you could draw a sketch of a graph. Okay. So that's what's going on. Determining a function from a table, from a set of points, from a graph. We'll eventually determine it from an equation. Okay. Next up, function notation. So again, something else you need to be familiar with. This shows up also on the ACT. So we know that we have an input. In this case, the input is called x. It does not always have to be called x. On a coordinate plane, it usually is. Remember, the input is also the domain. Then we have the output. The output is f of x when we talk about function notation. That is the range. And remember that f of x can also be called y. So if my input would have been a, then my function notation would have been f of a. Just recognize that, again, your input doesn't always have to be x. And then we have an equation. So f of x equals 2x minus 5. Remember, that could also be y equals 2x minus 5 because f of x and y are the same thing. So just recognize how we could write that there. Okay. And again, this might be f of a equals 2a minus 5. So whatever the input is, that just follows through in the whole problem. Okay, you're not going to see the a part today, but just recognize it does not have to always be x. But recognizing function notation. Again, this would be a linear function. This is the equation of a line. Okay, so that's how you could tell from a graph if it's a function that we've talked about, a linear function, a quadratic function, a cubic function. Okay, anytime it attaches the word function to it, you could use this function notation. Okay, and you also know that it's going to pass the vertical line test. So what we're going to do, our third objective is to be able to evaluate a function. So remember, we know it's a function for a couple of reasons. One is we're in the function unit, I just called it a function, but it has this f of x. So that tells us it's a function. So that means every time I plug something into it, I substitute a number into it, I should only get one number out. So we all should get the same thing out. The other way I know is that we have this x squared, and as we look through this is a quadratic function. So if we were to sketch a graph of this, it would be a parabola, and it would open up. Again, you don't have to sketch it, but just recognize a few things about it just looking at the equation. So we're going to do a few different parts to this. So part A, we're going to do f of 2. So if you're asked for f of 2, again, this shows up a lot on the ACT now, more and more than it used to, but they want us to be able to evaluate that. So what we're going to do is that 2 is our x value. Okay, it's in place of this x right here. So everywhere we see an x, we're going to sub in a 2. Now I'm going to put it in parentheses so I don't make an error there. So we have 2 squared plus 3 times 2 plus 5. And then we're going to use order of operations, or you can use your calculator to simplify this. So exponents first, so 2 squared is 4, 3 times 2 is 6, and we're going to add those together. So we have f of 2 is equal to 15. Now, what does this really mean? This means that if my x value is 2, remember f of x is y, so my y value is 15. So on this graph of a parabola, just recognize that the point 2, 15 lies on the graph. Now again, you're not being asked for that right now, but just recognize that because we're going to use that a little bit later. Your answer is 15, but recognize that that's the ordered pair on the graph if you were sketching a graph of this. Okay, on to the next one. The next one is going to help us with what we're going to be doing later on in the unit. So f of negative x. Now I will tell you on the ACT, they love to sub in negative numbers. So typically for part A, it wouldn't be f of 2, it'd be like f of negative 2 or f of negative 3 or something like that. So we're going to try it with a variable here. And we're going to be able to simplify with this variable. So again, we're going to do the same thing. Every time we see an x, we're going to sub in a negative x, and you want to use parentheses. So negative x quantity squared plus 3 times negative x plus 5. So remember that negative x quantity squared means negative x times negative x. So that's going to give me a positive x squared because we have two negatives that make a positive. 3 times negative x will be minus 3x. Don't know, I hit something there. Sorry about that. So minus 3x. And then we would just have plus 5. So f of negative x, there's nothing more we can do. We're going to simplify it here. This would be considered to be simplified. Simplified means that I've tried to get rid of any parentheses unless it's rational, so I should not have parentheses. And I'm going to try to combine all my like terms. So that's all I could do. So that's all you're expected to do is just eliminate those parentheses and combine any like terms. So again, we're going to be using that f of negative x in a couple ways throughout this unit. Part C, a little more involved, f of x plus 3. Again, we're going to be using something like this a little bit later. So now what we're doing is in place of this x up here that we talked about, every time we see this x, we're going to be putting in the quantity of x plus 3. So again, parentheses are important. So we have the quantity of x plus 3 squared plus 3 times the quantity of x plus 3 plus 5. So here we have to remember what it means to square it, and we talked about that on the last one, but to square something means to multiply it by itself. So please do not say that that is x squared plus 9, because it's not. Okay, I'll go ahead and change my color here. So if we distribute that, we're going to get x squared plus 3x and another 3x. So if you're comfortable saying plus 6x, that would be great, plus 9. Okay, so that's what I get when I distribute here, or x plus 3 quantity squared. Then we're going to distribute this 3 through, so plus 3x plus 9. And then we're going to have the plus 5 at the end. So then all we have to do is combine like terms. So we have an x squared. We have 3x, another 3x, so there's 6x, another 3x, so there's 9x. And then we have 9, 9, and 5. So 18 and 5 would be 23. So f of x plus 3 is equal to that trinomial, x squared plus 9x plus 23. Again, this is considered to be simplified. So really, whenever we start subbing in variables, we're just simplifying them. You can't evaluate them. Evaluate means to find a value like we did up here in part A. Okay, you're not going to be able to find a value whenever you have a variable that you're subbing in, okay, unless for some reason they would all cancel out. Now, I do want to mention something that will happen. I won't work through the whole thing, but kind of on a related note, in your homework, you might want to write this somewhere. Let's say you're given f of x equals 3x squared minus 2x plus 7. And let's say in this case, you're asked to find f of x plus 3. So we just did that. But what's different about this problem is you have this 3 in front of x squared. And so you have to make sure, again, that you're doing order of operations correctly. So if we sub that x plus 3 in everywhere we see an x, we were going to have 3 times the quantity of x plus 3 squared minus 2 times the quantity of x plus 3 plus 7. Now, to make sure that we're doing this correctly, we're going to bring that 3 down. But remember, x plus 3 squared means we're going to multiply x plus 3 times itself. Now, as you're working this out, what I would suggest is multiplying the two binomials together and then taking that answer, so I'm going to leave it in parentheses, times 3. Okay? You can distribute the 3, but you would only distribute it to one set of parentheses, and sometimes we want to do both. So you just have to be careful that your multiplication is correct. So if I distribute those, we just did that, x squared plus 6x plus 9. And then I have to make sure, we don't want to do this. This is what's going to happen. Some of you are going to do this. You're just going to bring the 3 down, and you're not going to distribute the 3 to the whole thing. So that's why you need to make sure that's in parentheses. So we would get 3x squared plus 18x plus 27. So that's what we get when we distribute the 3 times the quantity of x plus 3 squared. I guess I'll just go ahead and finish this out. Then I would distribute the negative 2. So make sure you're distributing a negative. So minus 2x minus 6. And then we would have the plus 7 at the end. So then to finish that up, make sure I can do my addition and subtraction correctly. So we have 18 minus 2, so 16x. And then it looks like 27 minus 6, so 21 plus 7 would be 28. So that would be f of x plus 3. So just be cautious there in your homework. Okay, I think you understand the concepts usually, but sometimes we make silly mistakes when it comes to multiplying, adding, subtracting, or at least I do. Okay. So the last things that we're going to do here are going to be looking at these graphs, and ignore the fact that I did not, those question marks I have written down elsewhere, so sorry that I didn't snip those for my iPad. So you have these graphs there in your notes. We're going to identify some important information from these graphs. So it says to use the graph of each function. Remember, it's a function, so it's passing the vertical line test. Every input has exactly one output, and we're going to do that to find its domain and range, so I'm going to abbreviate that, D and R. We're going to state the intercepts, so we're going to have to find the x-intercept, the y-intercept, any of those, and then we're going to evaluate it at the given value, and that's what's missing there. So as we get going here, let's start with domain and range. So the way, remember, domain goes with X and range goes with Y. So we're going to say X is an element of for the domain and Y is an element of for the range. And you do need to start doing that. Okay, I will start taking off on your test if you do not have those. So we did X was an element when we were doing intervals and solving equations. So it's just telling us which ones, which ordered or which coordinate we're talking about. So what we're going to do is when I think about domain, maybe I'll pull a line here. I want to think about left to right. So if I take this line and I move it left to right, right now, -5, that's an X value. If I look up and down, I do not see anything on my graph. I do not see anything on the graph until I get right here. So I get to -2. Okay, so -2 is going to be the first X value that gives me a Y value. Okay, so -2 there. Now notice -2 has a closed circle on it. So closed circles, just like when we graph for inequalities, are going to get brackets. Open circles are going to get parentheses. Okay, so if I start taking this line through here, okay, -2, -1.5, -1 still on the graph, -0.5, 0. Okay, I keep going until I get here. So I'm just going from left to right because I'm on the X-axis. So I'm trying to see which X values get to my graph. So it's from -2 to +1. So -2, 1. Again, -2 is going to have a bracket. 1 will also have a bracket because it's a closed circle. So again, if I highlight it, my X values were from here to here. For Y values, we're going to be looking horizontally, up and down. Okay, this is the Y-axis. You see the Y there. So I'm going to start at the bottom, and I'm going to go to the top. So I'm going from least to greatest. Okay, bottom to top. So if I I still don't have anything on the graph yet. I don't have anything on the graph until I get here. So we have to make sure we're looking at a Y value because remember, range are the Y values. So yes, I have a value over here. This is the point -2, 0. So my Y value is 0 and it was filled in. Okay, so notice the X value happened to be the lowest one and the Y value there is the lowest one. So then we're going to take this graph and we're going to keep moving it through if I can get it to move here. Okay, so 0 is the lowest. I keep going. There's a Y value of 0.5, a Y value of 1. Keep moving it up until I get to here. So my highest Y value is 3. 3.5 doesn't have anything on the graph. Okay, so it's from 0 to 3. So again, make sure you're looking at the Y values. So we would say 0 to 3. And again, 3 has a closed circle, so it's going to get a bracket. So for the Y, we were looking from here to here. Okay. So recognize kind of low to high. Those are the values you're looking at. So the next thing says identify the intercepts. So do we have an x-intercept? Well, yeah, it looks like it's touching the x-axis right there where we label that point. So we're going to say an x-intercept. I'm going to write it as an ordered pair, -2, 0. That's how I would expect you to write it on your homework or in your notes. On Pearson, they're just going to want it as, unless they say write it as an ordered pair, they're just going to want -2. Okay, but really intercepts should be ordered pairs. We also have a y-intercept. It is crossing the y-axis. Okay, it's crossing the y-axis right there where I put the point, so that would be the point 0, 1. It can have more than one x-intercept. It can only have one y-intercept. And again, think about that. That's because of the vertical line test. So again, if I take this vertical line through here, it's not going to let me grab it. Let me lock this in place so I can grab this line. So if I take this vertical line through here, I can't have another y-intercept because it wouldn't pass the vertical line test. But I could have an x-intercept here, and I could have it come back down and touch again. It doesn't on this graph, but it is possible. Okay, so I said that, and then I undid it. Sorry about that. Okay, the last thing then says to evaluate at the given value, and that's what you can't see here, so I'm going to write it in. So it's f of -2. This goes back to what I talked about earlier, and that is that this is the x value, remember, so we're looking for the y value. So if we were to sub -2, we don't have an equation to do that in, okay, but I have a graph. So what we're going to do is we're going to go to -2 on the x and figure out what's the y, and we've already talked about that. It's already 0. So that would be my answer there, that f of -2 would be equal to 0. Okay, let's go on to the next one. So on this graph, it's a little bit bigger here. Sorry about the bells. So on this graph, again, we're going to start with domain and range. So remember, domain are the x values, so x is an element of something, and range would be the y values. So y is an element of something. So if we look at our domain, again, we're looking left to right. So if we take this line through here, if I can grab it, okay, left to right on the x-axis. So it looks like we start at -3, and we keep going until we get to 2. So -3 is the beginning, 2 is the end. So think about, again, on the x-axis, you should be picking up numbers from down here. So we're picking up the numbers from -3 to 2. So -3, 2. -3 is an open circle, so it gets a parenthesis. 2 is a closed circle, so it gets a bracket. Then we look at the range, so we look low to high. So if I start working this up on the low side, again, we're looking at the y-axis for a number. So to avoid all these x numbers, these don't matter. We're looking for y value numbers. So it looks like 1. 1 would get over here on the left side where there's an open circle, and it only goes up to 2. I can't get anything higher than 2. I'm off the graph. So my range would just be that y must be an element somewhere between 1 and 2. And again, 1 had an open circle, so it's going to get a parenthesis. 2 had a closed circle, so it will get a bracket. Okay, and they don't always match. You might be wondering, like, I wonder if the open and closed circles match, and they don't always do that. So again, this would only be right in that section. It's a little fatter than what it is, but that's what we would have there. So we look for intercepts. There are no x-intercepts because it never touches the x-axis, but we do see a y-intercept. So we should be able to list that. I can't really tell exactly what it is. Maybe we say 0, 1.5. You'll be able to tell on your homework. But this is why, guys, when we're listing these intercepts, notice we're not using the element sign because these are ordered pairs. That's why we want to make sure we distinguish between them, because sometimes domains and range can look like ordered pairs, but they're not. They're a range of numbers. Okay, so 0, 1.5, it might even be 1 2/3, but we'll just estimate it there. And then the last part is evaluating. So in this one, we're going to evaluate for f of 2. So again, 2 is the x value. So if I go to 2 on the x, I want to know what the y value is. So this is the 0.22. So the y value is also 2. So that would be our answer there. F of 2 would be equal to 2. Okay, we're going to move on to the last ones. So these might be ones that maybe you want to try on your own. If you're not feeling confident yet, then you can definitely wait to do them, but you should be able to find domain, range, and intercepts, and then I'll give you the value here. So a little different on these, on some of these. So if you're not feeling confident, then definitely follow along here. But again, domain, x is an element of, range, y is an element of. So again, domain, look from left to right. So if we look from left to right and I start taking this line through here, looks like the first x value I get is -2 with a closed circle. The last x value I get is 1 with an open circle. So bracket -2, 1 with a parenthesis. Again, y, we're looking from low to high. So if I start taking this line through, there we go. Nothing, nothing, nothing until I get here. And notice it's not the endpoint. Okay, it's at 1 on the y value, and it doesn't have an open circle there. That's just a part of the graph, so that means it's closed circle. So that would be 1. Again, it wasn't an endpoint. It's not here. It goes all the way down to 1, and then we're going up to 5, and it has a closed circle. So 1 to 5 on the y, and both of those would have brackets on them. And remember, it's always low to high. Low value to high value as you're writing that. So again, the y's were from 1 to 5. If it helps you, the x's were from -2 to 1. So that's what we're looking at, the x versus the y. So do we have any x-intercepts? I do not see any. We do have a y-intercept. Y-intercept is right here where we found that low value on the y. So 0, 1, again, that's an ordered pair. And then it wants us to evaluate. So we're going to evaluate this one at f of -1. F of -1. So again, you're going to go to -1 on the x. You're going to go up to your graph, and that looks like a y value of 2. Okay, so on to our last one for today. So this you're going to find out, well, you should know from your parent functions, that this is an not an absolute value, excuse me, a square root function. It's just been reflected across the y-axis, so we're going to get into more of that. So starting off with domain and range. Maybe go ahead and try those on your own if you haven't tried one yet on your own. Would be worth your time to see if you can come up with the domain and range. So domain, if we look at the x's, so we take a vertical line through, you should notice there's an arrow at the end. So these are going forever in this direction. So even though it looks like I'm just a -6, that arrow means it continues. It's not an endpoint. It's not an open or closed circle. So this is going all the way to the left. It never stops. So on the x-axis, that would be -infinity. So it's going to go from -infinity, and then if I keep taking it through here, it looks like it's going to stop at 4. So keeps going forever this way toward -infinity up until we get to 4. So x would be an element. You can never reach -infinity, so it gets a parenthesis. 4 has a closed circle, so it gets a bracket. So again, we're talking about everything this way for the x. For the y, again, low to high. So the low value right here. Now, sometimes we want to say it's 4, but be careful. 4 is on the x-axis. Range is the y value, so that's 4, 0. So we want to pick up the 0 value on the y. And as we keep going, it looks like it may stop here, but remember this graph continues on. This graph's going to continue doing this. So that means that my y values are going to continue to increase. So they're continuing to go up. On the y-axis, up would be toward +infinity because my numbers are positive. Okay, so again, on the y-axis, we start here at 0, and we're going to continue and go up forever. So again, it's always low to high. So y would be 0, and that would get a bracket because it was a filled-in circle there at 4, 0, to +infinity. Again, -infinity should always go on the left. +infinity should always go on the right. So our x-intercept, it's crossing the x-axis at 4, 0. Crossing the y-axis at 0, 2. So again, remember in Pearson, they may only want the number 4 or the number 2. Just pay attention to what it's asking there in Pearson. And then f of 0, well, we just did it. Okay, we just wrote it right here. When x is 0, y is 2. Again, it's this point right here. X is 0, y is 2. So that's f of 0. So that's what we have for today, trying to determine if a relation is a function in a variety of ways. Trying to find domain and range from a graph. Okay, we're only doing the graph today, and then being able to evaluate a function from an equation and then also from a graph. So if you have questions, let me know, but you'll be starting or be working, excuse me, not starting, but you should be working on section 1.2 in Pearson. I hope you have a great day.